Hello everyone, today we are going to introduce you thermodynamic engineering applications, air conditioner. We will introduce it to you from the following parts. The first part is the information of our group members. The second part is project introduction. The third part is explain and apply the laws of thermodynamics. The fourth part is description of thermodynamic applications. They are our team members. Now let's move on to the second part, project introduction. Air conditioner as an essential appliance in our daily life. Its main function is to adjust the temperature and the humidity. Its temperature regulation range is generally controlled at 16 to 32 degrees Celsius, and unnecessary power loss will be increased outside this range. The main structure of the air conditioner includes four parts: compressor, condenser, evaporator, and expansion valve. They worked together to create the air conditioner function. Air conditioner as the main tool for indoor temperature regulation. Its working principle make full use of the first law and the second law of thermodynamics. Let's take air conditioner as an example and explore how it applies these two laws.
The third part is explain and apply the laws of thermodynamics. I will introduce a few important parts. The first part is compressor. The working process of the specified volume enters air pair in the air conditioner compressor. The internal and external threads rotate to meet each other. The side where the gas is compressed is called the high pressure zone. Instead, the screws are turned away from each other. The teeth continue to expand in size and are in the inhalation stage, which is called a low pressure zone. The second part is condenser. The pressure of the low pressure working fluid vapor sucked into the compressor from the evaporator is increased and then sent to the condenser. The gas condenses into a high-pressure liquid in the condenser. After being throated by the throttle valve, it becomes a high-pressure liquid. The low-pressure liquid is sent to the evaporator and absorbs heat to evaporate into lower pressure steam, thereby completing the refrigeration cycle. The third part is evaporate. It concentrates the solution or separates clay or particles from the solution by heating. It is mainly composed of heating chamber and evaporation chamber. The heating chamber provides heat to evaporate the liquid, and the evaporation chamber can completely separate the gas phase and the liquid phase. The first part is expansion valve. The expansion valve controls the flow of refrigerant by regulating the valve. If the reference of the expansion valve decreases as the refrigerant passes through it, it will cause the refrigerant flow rate to increase, thereby reducing the refrigerant pressure and temperature. The expansion valve adjusts the valve according to the control signal and system requirements to achieve precise control of refrigerant flow.
Okay, let me introduce the principle of refrigeration. First, during refrigeration operation, the indoor evaporator will compress the low pressure and low temperature refrigerant gas into a high temperature and a high pressure gas, and then discharge it into the outdoor consider to exchange heat with outdoor air. Liquefaction releases heat. After cooling down, it enters the evaporator and exchanges heat with the gas in the room. The liquid evaporates and absorbs heat. This reciprocating cycle achieves the cooling effect. It also utilizes the principle of evaporation, heat absorption, and liquefaction heat release. Okay. The following is the application of the laws of thermodynamics. The first law of thermodynamics applies to the refrigeration cycle, compress, and expansion value. Air conditioning system typically use a refrigeration cycle to absorb the heat indoors and then remove it outside. According to the first law of thermodynamics, the energy absorbed by the system is equipped the same of the work done by the system and energy discharged by the system. Components such as temperatures and expansion values in the air conditioning system compress and expect gas. This process involves the convection of energy. So the first law of thermodynamics ensures that the energy in this process of the system is balanced. And the second law of thermodynamics uses waste heat exchange and refrigerant selection. The application of the second term of thermodynamics requires that heat should be transferred from high temperature areas to low temperature areas, not to other way around in the design of heat exchangers. This law is used to ensure that heat is transferred in the most effective way, thereby improving heat transfer efficiency. And the second law of thermodynamics affects the selection of refrigerants. Some refrigerants are more susceptible for effective heat transfer under special temperature and pressure conditions. Engineers will consider these factors to optimize system performance.
The first part, thermodynamic application. If original indoor and outdoor heat is Q, when we use air conditioning, the indoor heat decreases delta Q. Heat becomes Q minus delta Q. When the indoor heat is reduced, it becomes cooler. When this heat is dissipated outside, the outdoor heat should become Q plus delta Q. In addition, air conditioning constantly consumes energy during use. According to the first law of thermodynamics, the consumed electrical energy W will actually be converted into heat, which means that the heat emitted from the outdoor gas will become Q plus delta Q plus W. According to the second law of thermodynamics, heat can't spontaneously transform a low-temperature object to a high-temperature object without causing any other changes. So as the team member mentioned before, air conditioning doesn't produce cold air, but achieves cooling by transporting hot air. Air conditioning continuously compresses and releases refrigerant to absorb heat indoors and release heat outdoors, thereby transferring indoor heat to the outside. Thank you.